Hello, everyone, and welcome to Building Privacy Resilient Identity. My name is Ankur Patel. I'm a program manager with the identity team at Microsoft. And with me is Daniel. Daniel is with our standards team, and he leads the standards work around verifiable credentials and decentralized identity.
Hey there, Ankur. Great to be here.
Thanks, man. So I want to open the conversation with why this topic is so important to us. At Microsoft, we believe that every person and business deserves an opportunity to achieve their best. We believe that starts with establishing trust. As Satya said previously, all of us will have to rethink about digital experiences. We create experiences that are rooted in privacy as a fundamental human right will be a bedrock for experiences going forward. Today, more than 128 countries have some form of legislation underway, whether it's drafted or in practice like GDPR, as in the case of European Union, or in California, it's CCPA. In each of these cases, organizations are facing increasing responsibility across a wide variety of topics when it comes to handling data, whether it's how we capture information, what's the minimum set of information that we can request of users, of employees, of partners, how do we use it, how do we present it to regulators and auditors, as well as data subjects to prove suitable use of such important information. This is not easy to do. So what if we could verify such information at scale while protecting privacy? This was one of the key questions we found ourselves answering for Microsoft, but then for our customers as well. What we discovered is that conventional privacy management focuses on finding personal information that has been collected. But often this information is trapped across many silos, whether it's for employee purposes or partner management or consumer management. And they have different regulatory requirements depending on the use rights associated with it, with the geography in which such scenarios are being experienced. And ultimately, that results in a lack of actionable insights for what information does a business need to retain and manage on an ongoing basis, versus we needed it at some point in time. The net result of it is a cumbersome, complicated, and high level of assurance and risk processes around keeping track of information and proving compliant use rights associated with it. So we challenged ourselves to imagine a different form of identity system. So this slide used to have a title called Incubation Hypothesis for us 4 years ago. Now it's the North Star of identity at Microsoft. We believe each of us needs a digital identity that we own and control, one which securely and privately stores all elements of our digital identity. Now, us here could represent a person, a business, maybe a device, maybe even an application or a service that represents such persons and organizations. But ultimately, we also believe that it needs to fit seamlessly into our existing lives or internet or business processes. It would be a failure if we have to reinvent a whole new technology stack in order for such a solution to be useful. So let's take a look at a demo of what this new experience could look like. So here on my screen, we have a flow where we're trying to remotely onboard an employee. This is a very common scenario that just about every business faces, onboarding new employees, partners, customers, or anyone else for that matter. So let's imagine we received an email to welcome us to the company. In this case, we are Matthew Michael, and you're asked to, as is often the case, perform background check. In our case, number of ID verification partners around the world are leaning in with us to explore identity verification based on open standards. So here's what Michael's experience could look like. In this case, they are now clicking through and going to a partner website. In this case, it's TrueID, a fictitious ID verification company for this demo. And Woodgrove, as a customer, has agreed on a policy to verify their selfie and their government-issued ID. Now, of course, this experience could be as complicated as the customer would like to make it. It could even include come see me in person. But given COVID and remote verification and remote onboarding being a commonplace now, imagine you're asked to upload a selfie and a government-issued document. ID verification partners today are capable of not only matching the selfie of this person to the state-issued document. In this case, it's a driver's license, but they can do so across 192 countries, 6,000 different document types. Now, of course, this is a commonplace when it comes to financial industries like banks. They have been doing document verification such as this for a long time. But what's different now is every user can just as easily now scan such a QR code that is issued at the end of this verification process, type in this PIN, which establishes trust for remote signing. And upon doing so, I can accept this card just like I would have accepted a card from my any digital wallet today on the internet. If we tap on this credential, it shows not only the name was verified and then this was a genuine document, the selfie was verified, but also the address that goes with it. Now, such a credential can be presented back to the employer, and we can say, I've completed my background check. What used to take days, time and money, and personal information being peanut buttered all over the internet is now under the user's control. They can present such a credential by just scanning a QR code. And upon verifying, the employer can give me access to the employee portal. The employee now can continue their journey. Instead of getting usernames and passwords being issued again, they can get a digitally signed credential from their employer, which I can take possession of by giving my employee ID number. And now I have these two credentials. One of the first things that most people do when they get their new job is order some sort of computer. So we've all gone through retail websites like these and signed up for corporate discount. So in this case, I'm going to sign up for proving that I work at a given company by using usernames and passwords. But how many such websites could a retailer federate with? So instead, in this new world, they're able to scan this QR code and prove that they work at Woodgrove with the tap of a button. And I get my corporate discount. Furthermore, if I click on this credential, recent activity shows when was this credential issued, to whom did I present, and the user has far greater insight into what information they're sharing, with whom, for what purpose. So this is a quick overview of what's possible today. So in this demo, we just looked at how, based on open standards, issuers can issue credentials that can be used at a wide variety of places and not require the user to create different usernames and passwords with every website they interact with, and further give control to the user for such information. So we believe by extending the familiar multi-factor authentication, so in our case, what you noticed was Microsoft Authenticator app being used to not only prove that you had possession of some credential, but present it to a wide variety of websites, just like you were used to presenting it for your own company. So on the left side is your Microsoft Authenticator that you're used to doing multi-factor authentication. On the right side, what you're seeing is the evolution, which includes now these open standards-based authentication and presentation flows, which enables the user to have a more verifiable way of presenting their information, a more transparent way to understand what was shared with whom and for what purpose, and ultimately have a convenient way to track such information and how it's being used. In the coming weeks and months, we'll be building some features which allow the user to further restrict use rights directly from their phone, instead of having to figure out what are all the websites I have visited. So this work is based on open standards. A lot of this work started in Decentralized Identity Foundation, and the standards have been ratified in W3C. The bedrock of this technology is based on decentralized identifiers and verifiable credentials. Now, in a traditional identity system, a user has a user agent, which is provided by the identity system, such as a Microsoft account or your favorite social network. But the user doesn't have the actual keys under their control. They're sitting in a directory system in a centralized identity provider role. In a decentralized system, the users have a user agent, like Microsoft Authenticator being an implementation of it, where their biometrics or PIN are used to protect such keys. And we use blockchain to publish the state of the latest set of keys. Using a client implementation of Universal Resolver, an open source library, all participating parties have equal access to resolving these identifiers and the state of keys. As a result, Any application can request a credential of the user, verify independently who issued it, and if this is the user who should be presenting it. This is very different than a traditional identity system where anybody possessing a username and password can pretend to be that person. In such a decentralized world now, we can decentralize verification and establishing trustworthiness. What I just demonstrated to you was our platform implementation of such open standards. You can use Azure Active Directory to configure and issue such a credential, such as a verified employee credential. You can use our developer APIs and SDKs to request and verify such information. And the end user wallet is Microsoft Authenticator to request and verify such information. We believe such a tech approach can help transform our everyday scenarios to be more trustworthy, faster and easier for users to use, and ultimately result in reducing cost and complexity for everyone involved, while improving control across each of the stakeholders, whether it's issuers, verifiers, or end users. But much more work remains on going beyond just enabling this basic control. We believe we can do better in terms of limiting disclosure and correlation. So I want to invite Daniel Buchner from our team, who leads our standards work on inventing some new ways with the community and collaborating with them for imagining new ways that we can restrict such correlation and improve privacy. Daniel?
Thanks, Ankur. Yeah, like Ankur was saying, we have more to do on the privacy front. So I'm going to walk you through a few of the things that we have planned to enhance the privacy of the systems that we're building. Now, one of the first things we want to do is reduce the correlation points in some of these identity systems. When you're transferring credentials, getting them issued by issuers, users presenting them to verifiers, and verifiers doing revocation checks, for instance, there are many points at which there's communication between these parties where you can essentially disclose what and when is occurring and when you may not have to. So all of those little disclosures can leak little bits of privacy information. And working with the community, we have ways that we're going about trying to remove some of those. Some of the ways we're doing this is by implementing zero-knowledge proof credential schemes like BBS Plus and some snark-based schemes to really move some of those communication channels away altogether. And so to illustrate this, right now as a user, a common flow in some of the basic credential schemes is going back to the issuer for sort of this just-in-time generation of a credential that they've been issued to present it to the verifier. Now, this presents a side channel in the sense that the issuer then can learn of, obviously just about when you're going to present a certain credential. To remove this, we want to be able to generate derived credentials on the user's device without having to go and speak to the issuer. So in this example here, you can see what occurs is now the user can cryptographically derive a credential instead of going back and having one issued and present it directly to the verifier. What that does is removes that channel where the issuer is then able to see what's happening. It's great for the user, same information, the verifier can verify, the business process can still go on. Another thing that we're doing is implementing the W3C Status List 2021, which is a privacy-preserving mechanism by which a verifier can check with an issuer to learn whether a credential has, for instance, been revoked. Might be like a driver's license or something like that. Today, currently, some systems disclose the exact credential or user that the verifier is inquiring about. But with this Status List 2021 standard, we're able to remove that so that we're obscuring from the issuer who exactly is being inquired about and what credential they're inquiring about. So the next thing we're doing for privacy is limiting disclosure. And this just means like not disclosing to verifying parties or any other external parties any information we don't have to. Right, we certainly want to facilitate the disclosure of information that makes business processes possible and smooth interactions between users and verifiers, but let's eliminate what we don't have to disclose. And how we're going to do this, again, is by implementing certain zero-knowledge proof schemes like BBS Plus and SNARKs that allow us to, as you can see here on the right, simply identify information in this particular exchange, the street and city, that don't need to be disclosed to a potential verifier, and only present the information that does need to be disclosed, like the birth date. With schemes that enable selective disclosure and exchange transport schemes like presentation exchange, we're able to remove those fields altogether and present to the verifier just the information they need for the business process they're engaged in. So last thing we're going to do. So additionally, we're going to provide an advanced capability to mask data altogether. We talked in the previous slides about how we were going to reduce communication in side channels. We were going to eliminate unnecessary data disclosure. And then the advanced capability we want to offer is the ability to obscure certain data even though you're presenting it. And let's talk a little bit about what I mean. Over here in this example, carrying on from the last slide, you see that we're disclosing the user's birth date. Maybe that's required by the business flow, but it's for the purpose of understanding whether the user's over 21. Now, in this exchange, we're given the exact date, but we don't have to. If we implement certain snark-based ZKP predicate schemes and just presentation exchange features, as well as offer some good libraries out there for developers and companies that are implementing these schemes. What we can actually do is provide people a mechanism to transition from disclosing raw values to disclosing simple predicates. And what predicates are is basically computation over data that allows you to give people a true or false, a cryptographic true or false as to whether it meets the criteria for a business process. These are some of the more complex schemes out there. They certainly require being honed and developed further. We are really excited to work with the community on that. To advance some of these more privacy-preserving capabilities, we want to partner with you out in the community to collaborate and contribute to these efforts. Now, that could look like partnering with us to identify privacy issues, accelerating open standards work that happens in the Decentralized Identity Foundation and the W3C, as well as partnering with us on integrating these systems into your own products to help kickstart the issuer and verifier ecosystem. You can learn more about this at aka.ms/ownYourIdentity. Ankur?
Thank you, Daniel. As you can see, while we've taken as a community a good set of first steps to enable users to have greater control over how credentials are issued, presented, and verified, there's much more we need to do to limit correlation, enable users to have greater control how and when that information is disclosed and have some say in it, and ultimately even prevent needless disclosure, such as what zero-knowledge proofs can enable. However, a lot more work remains of taking these ideas. Some of them, like zero-knowledge proof, are many decades old. Bringing these ideas to work with the modern internet, with current applications that run on OpenID Connect, for example. So getting these protocols, standards, and implementations all to work together is going to require a partnership from all of us working together. So we really look forward to partnering with you on building these new class of issuers and verifiers for a more trusted internet. I would love to share with you some of these resources to help you get started. As Daniel mentioned, Decentralized Identity Foundation is a key working group, industry working group, where a lot of these ideas are discussed. We've published our own white paper around this work, and it describes work that needs to occur over many more years to come. Some of it we've done, much more work remains. There's a quick overview video, there's a developer walkthrough, documentation, and an ongoing blog series that describes all the details from how might such a system scale, how might recovery work as a self-owned key recovery scheme. And there are many more topics that the community is discussing, but these might be a few set of good resources to help you get started. Thank you very much for this opportunity to share our work and requesting your help to help us go build a more privacy resilient workplace and ultimately a more trusted internet. Thank you.